Some folks like to 3D print on glass sheets, but the glass sheet can come with its own set of issues. So let's talk about it. Hello everyone, Chris here, and today this one comes with just a little bit of backstory. A couple of months ago, one of my Patreon supporters reached out and said there were a lot of users having issues with the Creality Glass Sheet. Now this sheet is the one that comes on like the Ender 3 V2, but you can also buy them after the fact and upgrade your Ender 3 style printer. So I thought it would be worthwhile me buying one of these sheets and putting it through its paces. Now there's a lot of reasons why you might want to print on a glass sheet. There's a lot of tips that I can offer you on how to be successful with one, as well as modifications you can make to your Ender 3 style printer that would help you along the way. So that's what we're going to go over today. Now, I did this video in a couple of different sections, so it might not be completely cohesive, but we're going to do our best to line it up. So let's just start by taking a look at the sheet. This is one of these micro-porous type materials, kind of like Ultra Base from Anycubic, not exactly, but let's take a look at it anyway. So here we go. This glass sheet does come on some of the Ender 3 printers, like the version 2, but you can buy it as an upgrade. So if you do that, here's what you're going to get. It's just a box with some foam and a glass sheet with this type of coating on it. What we're trying to figure out is if this coating is causing problems with adhesion. I never really had a lot of problems with my V2, but this is a newer sheet than the one that I have, so maybe there are some new problems that we need to figure out. So we'll get the bed out, and we can peel off this plastic. Cue the music. Now that we're all satisfied, let's just go ahead and throw it on a printer and try to do a print without doing any cleanup, any prep work, just to see what we get. And installing these beds, you have a couple of different options here. Now, some of the kits I have seen just come with the traditional binder clip. You can put it on there, throw the clip on there, but it always seems like I knock this off in one way or another. I like to do a prime line either over here or in front, and I'm always running into that clip. So not my favorite method. Now there are things like this. This is actually a picture clip used to hold together picture frames. You can get them on Amazon. They kind of work, but this lip here really isn't wide enough to hold that bed on that well. The method that I went with today is called a Swiss clip. Now you can get these from a couple of different places. I first saw them with E3D on the tool changer. They can be somewhat surprising when you bump one and they come flying off, but in a lot of different examples, a lot of different printer configurations, these work great. It just slides on, and that foot will hold the glass down. You have to be kind of careful depending on what type of heated bed you have. You don't want to scratch it up under here on the PCB, or if you have a silicone heater, but they do work pretty well. My favorite one is actually the ones that Creality uses stock, like on the Ender 3 V2. I'm not sure exactly where you can buy these, but it's more like that picture clip, but it's a lot wider up here, and they don't get in the way near as much. They just slide on, and they're made pretty much for the width of that 3mm aluminum bed and that glass sheet. I'll search around and see if I can find a link to these, but I do actually like those the best, so well done, Creality. Now once you have your bed clamped down however you wish, you're going to have to adjust your Z height because this does add some to the frame. You could probably get away with rolling your bed knobs down and get clear of that nozzle, but you want to be careful because this metal plate under here, you can bend it really easily, and that can cause a host of different issues. So be careful how you do that. And enter the first modification that I want to show you. So here's a look at the stock Endstop setup on your Ender 3. This is a newer version, maybe about a year old. Some of the older versions on this plastic piece, they didn't have this foot. This foot actually sits right on top of this extrusion to keep it from going lower than this. You can conflict with some of this hardware down here if you have to go lower. Most of the time, this is as low as you want to go. We're more concerned with adding things to the bed that we'd have to raise it. So you can raise these, just loosen these up and slide them up, but there's really no way to increment. It's pretty difficult. I'll pull it off of there real quick. You can see it's just the Endstop PCB, a couple of T-nuts, and it just sandwiches on that extrusion. So the X carriage collides with it to stop that Z-axis. So I whipped up this 3D printed part. This makes you able to adjust your Z Endstop to either dial it in or compensate for adding something like this bed. I'll pull it off there and show you what I did. This isn't my original design, but I did change it up a lot. The credit for the original design goes to user Mach0 over on Thingiverse. Here's a look at it. It's not a bad design at all, but it didn't fit my needs exactly. So I did a lot of rework. So here's my version. This is the base. I just made it so you could house an M3 Nylock nut here at the bottom. And then I used the original knob. You have a regular M3 nut, and this is an M3 by 25 millimeter screw. And then the sled piece where you actually mount the Endstop switch, I made it so you could add heated inserts. And I'll leave a link to this model and all the parts I used. But then you can just use your Endstop switch, put it on those inserts. Then your knob will just thread into this Nylock nut on the base piece. That Nylock nut helps it stay in place so you can do your fine tuning. And then you have another Nylock nut that you can just slide in this sled part right here. And then just slide your sled into your base piece. And all I do is just thread this on to that Nylock nut. But to hold the Nylock in place, I just use like a flat blade screwdriver. You don't have to worry about getting it tight. This is just so that that sled can go up and down. It can follow that threaded screw. So I just hold it in place and turn it a couple of threads onto that Nylock nut. I just turn it a couple of turns until I feel that Nylock nut in here start to grip. And you might think it would be better to make that Nylock nut captive, but that Nylock nut has to turn in there so that it can go up and down. It has to turn freely. So this is the best solution that I came up with, but it does really help you be able to fine-tune this Z Endstop. And then you can just put the whole thing back on the printer. This ledge is made to set on that extrusion. And there's another look at it back on the printer. Now you can go ahead and fine-tune adjust your Z Endstop. On this design, turning it to the right, that's going to make it go up. Left, make it go down. And when you're making these changes, the process I like to use to get this dialed in is just heat up to whatever your printing temperature is. We'll just go PLA for this one, so we'll set it to 60. When you're up to temp, just go ahead and auto home. Should be able to do all this from the screen. And once you're auto homed, the Ender 3 model is actually pretty easy to adjust the Z. You can actually see it pretty well because it's over here in front and to the side of the bed. So I like to just get bed eye level with it and start adjusting that knob. Right there you can see we're actually a little too low. If you move the bed by hand, it's actually touching it. So we're going to raise that Z Endstop up a bit. I'm going to go clockwise to the right a couple of turns, and let's rehome Z. Now you can see this time we're a little higher. Now we're not touching the bed. So I like to get this as close as I can, and then the rest of it you will level with your bed knobs. So let's go counterclockwise just a little bit. We'll home Z again. And that gets us a little closer. That's good enough. The rest of it should just be a standard level. We can use a piece of paper if we want to. With Z homed, I just run around usually with a Post-it and adjust the knobs to where it's just barely touching the paper. Remember, you have the teeter-totter effect here, so you adjust one, you might have to adjust the one across from it as well. Go around, check all four a couple of times, and when you're happy with that, you can check the center one just to make sure you don't have any bow or anything, and you should be ready to print. So the install of this sheet is really straightforward, and if you use that adjustable Z Endstop that I showed you, it can be even easier. It's a pretty good modification for pretty much any Ender 3. You might want to check it out. Now you might have noticed that this bed has already been used. I showed the bed brand new at the beginning of the video, and then I went to testing, but when I started the testing, I wasn't able to make the adhesion on this bed fail. A lot of users have reported issues, but I didn't have any. Even the largest prints I tried all stuck just fine. But there could be a couple of issues here. One, Creality could have just had a really bad run of these beds that got into users' hands, and they weren't made properly. So now they've been resolved with the one that I bought. That's very likely. Or maybe the users weren't getting it quite clean enough, or there was something else wrong with their machine that caused this issue. So let's talk about a couple of those issues now, and maybe this will help a few people out. So let's start super simple, cleaning a bed like this. I like to start with the least aggressive method possible. A lot of different soaps that you're going to use, like dish soap, might have lotion in it. I like to use this stuff. There's pretty much nothing in it. It works really good to clean these beds. This is 7th gen. Look for the free and clear. You're not going to run into any issues with added oily products in this soap. So start there to clean off a surface, just in case other solvents might damage it. And then from there, I just go isopropyl alcohol. This is 90 to 99% in a spray bottle. It works the best. It's quick and easy. It's not going to hurt your Creality surface. So try that next. With your glass sheet all the way cooled down, just spray on quite a bit and then wipe it off with some sort of lint-free towel. I have good luck with paper towels. Shouldn't be a problem at all. And that's going to get rid of any grease from your fingertips or anything from the print. That should get you back into good shape. Now, Creality does mention using acetone. I wouldn't try acetone on this type of surface. That's a pretty severe solvent. I would think that you would probably melt this stuff, whatever they make this coating out of. It should be ceramic, but I still wouldn't try it. From there, if you had a PEI sheet or something, I'd probably recommend going steel wool or even sandpaper, but not on this surface. If you can't get it with soap or isopropyl alcohol, there's probably something wrong with the surface. And honestly, this sheet might just wear out quickly. Now, I have used this on dozens of prints so far, and I'm still having pretty good luck, but maybe here in the short time future, it might just go ahead and wear out and it won't stick any longer. In that case, you could always flip it over and put some glue stick or hairspray on it if you wanted to, or a PEI sheet. That'd work fine too. Just make sure you try to clean it as good as you can before troubleshooting anything else on the printer. So just the product failing might be the problem altogether. Time will tell. I'll continue to test this surface, but I really haven't had any problems on my V2 either. So we'll see what happens. But again, I did run a lot of tests for this video, including these really large squares that just kind of seemed to stick. So I tried to get that first layer perfect, maybe even just a little bit too high. You can see where it stuck really well on this big object here in the center, and then out here it was a little less stuck down, but it still didn't break free. It stayed on there. And again, I tested with multiple different filaments, different colors, just to see different thicknesses. Maybe it held in the heat a little bit better if the part was thicker. I never really ran into any issues. And when you add something like this glass sheet to your heated bed, it's going to change it. It's going to change the way things heat up and how it puts heat into your part. So keep that in mind. You might have to increase heat or decrease heat depending on what you do. And if you take a look at the FLIR footage, this is 60C. You can see some of the hotter spots are around 52. That thermistor is setting on the bottom of that aluminum bed, so the top surface of that glass temperature isn't actually what you're reading. And that's what you want to be affected. You would like to be the effective temperature, you would like it to be on top of that glass. So keep that in mind. And remember, the whole purpose of a heated bed is to keep that filament you're putting down somewhat malleable so it will stick to your bed surface. And there's a lot of good tests out there that you can run to see the quality of your first layer. And I'll do my best right now to show you what a good first layer will look like. And for showing the first layer on the whole bed, this is actually one of my favorites. There's a lot of great ones out there, but I like having all of the boxes so you can kind of judge which corner might be a little higher or lower, or if the center is. So we'll go ahead and run this test. And here's our complete test print. We actually have some pretty good examples of both conditions. Too far away from the bed, too close to the bed. So let's take a look at some of them. Some are actually pretty close to exactly what you would want. Here in the back left corner, this is just a little bit too much squish. You can see all of the layer lines are kind of smashed together. And then around the edges, it's almost like it's bulging, over extruded almost. That's just because it's too close to the bed and there's no place for that filament to go. And then the opposite corner, the front right, this is a little too far away from the bed. You can see we have gaps in the filament here, and you have gaps when it's trying to connect it to that outer perimeter. Over here in the corner, it's actually just a little bit lifted where it didn't stick at all. If you look at this print from the top, you can see down in here where it wasn't able to lay those lines down. It wasn't fully connected with the bed, so it didn't connect with the other layer lines on the print. So that's too far away. And then you have the front left corner. Now this one isn't perfect. You can see we're missing just a little bit of extrusion right here, but this is about as good as you can get on one of these sheets, I would guess. Clean it extra good, get that first layer just right. You can probably get it better. We're a little bit too close in this corner, but the rest of that print, that's about what you want to see. It's nice and even. If you look at it over the top, there's not going to be any gaps. There's just the proper amount of squish to keep it on the bed. Maybe a little too close, you could back out a little bit, but we're talking less than 10 micron here. So there's a look at your first layer. Now remember, this is just a quick and dirty version for this video. I'm sure you can get yours dialed in much better. This is just some examples of what you might want to look for when you're dialing it in. Now there are a couple of reasons why you might want to consider this glass sheet. One of them being if your Ender 3 bed is warped. Now there's a lot of different things that can cause this, but it is a pretty common problem. But remember, if it's really warped, that glass sheet could assume the shape of your heated bed. It's not going to always be flat after you get it clamped down. It might help, but it might also be in the same shape as your current heated bed. So take that into account. Also, there are some slicer settings here that could help you get a perfect first layer, or at least mitigate some of the issues if you do have a warped bed. The main setting being your first layer height. If you printed at, say, a 0.2 millimeter, which I usually do, you can increase your first layer to a 0.3, and that would give you some extra filament as well as extra squish on that first layer to help it stick down to that bed. If your bed was just a little bit out, this would be enough room to help you keep that first layer down while you printed all the other layers. Also remember, the bigger the part that you have on your heated bed, the higher temperature you might need. It might not always be as hot on the edges as it is in the center. So the bigger the part, the higher the temp. Also remember, you do have the options for a raft or a brim. Now I think these are kind of old school given the print surfaces that we have nowadays, but they're still available. So brim, that's going to put a little extra material around the outside of the part to give you a bigger footprint to make it stick to the bed better. I'll just make it 10 millimeters here so you can see it. So you can see around our benchy, you have a single layer brim. That might help you if you're having adhesion problems. And raft is still an option. Let's put 3 raft layers on here. It's going to print a bed that you put your print on. You can see it right there. Not that many years ago, this was kind of the go-to method. Even the factory defaults on some 3D printers would always go with a raft. just to compensate if the bed wasn't completely flat. Really not much of the case nowadays, but it's still there if you need to try it. And the last set of tips that I can give you to help you get your print stuck down to your bed is all about extrusion. Now that can be a really complicated subject. I'll do my best to leave some videos in the description below that explain it a lot better. But if your filament diameter isn't correct, your extruder isn't doing its job, your nozzle's jammed, there's all different kinds of things that can cause you to not lay down enough plastic to get that print stuck down. So check out all that info in the description below. So hopefully you found some of these tips helpful. I do believe that these beds tend to wear out over time. You do see just a little bit less adhesion the more prints that you do. I'm even starting to see it now. But again, I will keep testing and see how it goes. That's it for today, and I'll see you really soon on the next one.